when you say dynamics, when you hear the word dynamics, it means that what you are looking at motion of a body. You're looking at the motion of a body and what causes the motion. You're looking at motion of a body and what causes the motion. Okay. In general, motion is caused by a force. Motion is caused by a force. And that's the reason we define force as anything, any agent, whatever that can do what? Change the position of a body. And don't forget, whenever the position of a body changes, the body is said to have undergone what? Motion. So, motion of a body is caused by a force. Without a force being applied on a body is not supposed to what? To move. A body is not meant to move if there is no force applied on the body. So dynamics is an aspect of mechanics. An aspect of what? Mechanics that deals with the motion of a body, and forces causing the motion of the body. That's dynamics. We can just say that word. Dynamics is actually equals motion plus force. Motion plus force. There's an aspect of physics or mechanics that considered only the motion of a body. Its duty is just what? To say a body moves, a body changes position. It does not have interest in what causes the motion. That aspect of physics that consider the motion of a body without considering that only a force can make a body move is called kinematics. So kinematics is an aspect of mechanics which deals with motion of the body, with the forces causing motion not considered. Forces responsible for the motion is not considered. Now, kinematics was, the concept of kinematics was first introduced by a man called Galileo Galilei. Galileo Galilei considered motion without considering what? Forces responsible for motion. So he was blinded to the fact that what? A body can't just move on its own. He just believed that what? A body can move. A body moves. Then dynamics was introduced by Sir Isaac Newton. The concept of dynamics was introduced by Sir Isaac Newton. Newton emphasized that a body will never change its position unless a force acts on that body. Newton emphasized that the position of a body, the state of a body, will never change unless a force acts on that body. And that's what we call what? We call the laws of dynamics. Laws of dynamics. Laws of dynamics are also called Newton's laws of dynamics are also called Newton's laws of motion. All the laws of dynamics are renamed or can be renamed as Newton's laws of motion. So we can say that what Newton's laws of motion are called laws of dynamics. Like I said, Sir Isaac Newton believed that what a body moves and only a force can make a body to move. He also said that what if a body will stop moving, as well, he said what only a force can also make a body moving. These are things you have to recognized in dynamics. Now, let's look at kinematics. If you can recall, we have kinematics. We have done this under what? Our normal linear motion. We have seen this in motion under what? Gravity. Okay, and in all of this, we didn't consider the force response for motion. We only said that what? The equation of motion. We wrote V equals U plus AT. We wrote V squared equals U squared plus 2AS. We said what? S equals UT plus half AT squared. Okay, we said S is U plus V all over 2 times T. Okay, all these are equations of motion for kinematics, where forces responsible, forces causing the motion, are never what considered. But in dynamics recognize, just watch please, dynamics recognize all the equations, all the kinematic equation of motion. Recognize all the equations of motion. So in dynamics, we have all the equations, all these equations. V equals, you can see, V equals, what again? V square equals, S equals, and the last one. All these equations are recognized in dynamics because, of course, when the body moves, the body may have acceleration, may not have acceleration. The body may start from rest or have initial speed, and so on. So the body will cover a distance S. So these are relevant in dynamics. But in addition to this equation of kinematics, equation of dynamics includes all kinematic equation plus which one? Plus F equals to F. You don't have to put plus there. So all equations of kinematics, in addition to what? F equals to MA, will be called the equation of what? Dynamics. Will be called the equation of dynamics. So we must take note of that. So dynamics equation includes equation of motion and kinematics what? Equation. Now, Sir Isaac Newton explained his idea giving what? 3 laws, which are called Newton's laws of motion. So right, we have Newton's laws of motion as propounded or given by Sir Isaac Newton. We have Newton's laws of motion. Now, in the Newton's laws of motion, what do we have? We have 3 laws. So the Newton's first law of motion, Newton's first law of motion, Newton's first law of motion says that what? It states that a body, watch my word, it says a body will remain in its present state. A body will remain in its present state unless a force acts on it otherwise. I want to watch that word. A body, it says, a body will remain, watch that word. A body will remain in its what? In its present state. Will remain in its present state unless a force acts on it otherwise. Which means that what? If a force does not act on that body, the body will not change its state. It will remain in that state. How many states can a body have? How many states can a body have? This is not solid, liquid, and gas. No. How many states can a body have? A body can have 2 states. A state of rest and a state of uniform motion. A state of rest and a state of uniform motion. These are the two states a body can have. A body can remain at rest if a force does not act on it. A body can remain in motion if a force does not stop it. That's what the first law is saying. It says a body will remain in its present state unless a force acts on it otherwise, meaning you remain at rest for life or remain in motion for life. Now, the first law of motion, Newton's first law of motion is called the law of inertia. Law of inertia. Newton's first law of motion is called the law of inertia. Now, what is inertia? Inertia means what? The reluctance. Watch that word. Inertia means what, please? Watch the word. It means reluctance. Inertia means reluctance of a body to change its state. Reluctance of a body to change its state. That is the meaning of inertia. The reluctance of a body to change its state is called inertia of a body. Watch that word. A body is reluctant to change its state. If you notice very well, and the first law says a body remain in its present state. That's the same thing. That's the same thing. A body remain in its present state if no force acts on it. Inertia means reluctance of a body to change its state. That means a body will have, you can say what? A body will have a high inertia if no force is acting what's on it. Remain in its present state. I mean, if it's at rest, remain at rest, it's in motion, it continues to be in motion. So that's inertia already. Reluctance of a body to change its state. Now, what are the things that can affect inertia of a body? The inertia of the body is majorly influenced by the mass of the body. By the mass, don't mind me, by the mass. It's influenced by the mass of the body. Now, how? Let's explain that. The inertia of a body depends on the mass of the body. What does that mean? This means that if a body has high mass or large mass, if your mass is large or high, you have high inertia. What does that mean? If your mass is high, large, you are big, you are heavy, you have high inertia. Don't forget, inertia means reluctance of a body to change its state. Let's look at a very good example. Dust comes from rock. Yes, don't bother. It's a dust, it's sand. Okay? You can break, you can pieces rock and become what? It could become dust. So don't bother quoting me. Dust comes from rock. Okay, because you can break down rock to give you powder, dust. Now, breeze can blow the dust easily. Breeze can blow the dust easily. That means the position, the state of a dust can be changed by ordinary breeze. Why? Very low mass. Dust has very low mass. Its mass is very small. A rock, breeze can never blow rock. How? To even break rock down, you need a lot of work to be done. Why can't breeze blow rock? Why can't breeze change the position of the rock? Because the rock has very high mass. Because the rock has high mass, it will be reluctant to move. And the rock has very high inertia. That's what rock and dust. A car and a trailer A car and a trailer. Just watch and pay attention. A car and a trailer, which of these can easily move? A car and a trailer, start them at the same time. Which of them will
So your voice is faint.
Okay, thank you. A car and a trailer, which of them can easily move when started? Car will move. In fact, car is gone. Trailer is still trying to warm up. Trailer is still trying to go. Why? Trailer is heavy. It has very high inertia. Car is light. It has low inertia. Because car is light, we say what? Reluctance of the car to move is low. To move at all. It has no low reluctance to move, meaning low inertia. Trailer has high mass, high inertia. To move is problem. Also, to stop moving when in motion, when in uniform motion, to stop moving, if you apply the brakes of a car, the car stops almost immediately. That's why if you just mistakenly cross the road and the car is coming, the car can still apply brakes and the car can still come to rest and save the person. If a trailer is coming and somebody just move in front of the trailer may hit the person because of a very high inertia. Because the very high inertia of the trailer. So the trailer, watch what we are saying. The trailer is reluctant to move when at rest. Is reluctant to stop when in motion. A car has low reluctance to move when at rest, has low reluctance to stop when in motion. If you have heard this, what is it called? This wrong statement or rumor before, that you don't cross in front of a train, that the magnet of the train will attract you. If you have heard that before, that's rubbish statement. You don't cross when the train is coming, everybody have to wait. Or else if you go and cross when the train is very close, it will attract you. That is wrong. It's a very wrong statement. What they're trying to say is to save your life. That if you want to make a train move, to make a train to move is work. The train is reluctant to move. If you want to make a train stop moving, a train is also reluctant to what? To stop moving. So a train has very high inertia. A train has very high inertia. So to stop moving, to move it is problem. To stop moving is problem. That's why when a train is about to stop or a train is coming, people will have been their things because when the train sees you, you cannot just apply brakes and stop because it has very high inertia. Its mass will be pushing it forward. So that's noted. That's what it's called first law of motion. First law again say that what? A body remains in its present world state unless a force acts on it otherwise. A body at rest will remain at rest. A body in uniform motion will remain in uniform motion unless what force acts on it otherwise. That's the first law. Newton's second law of motion.
So I can't hear you. So I can't hear you.
Okay. Okay.
We can hear you now.
It's on it now. So for the second law, Newton's second law of motion. Newton's second law of motion. Now, what the second law saying? The second law says that, it's centered on momentum of the body. And I was asking you, what is momentum? Momentum is a product of the mass of a body and its velocity. That's what momentum is. Okay? Newton's second law of motion states that the time rate
So I can't hear you.
we have, like I said, the Newton's second law of motion states that, you're writing, second law of motion states that the time rate of change in the momentum of a body is directly proportional to the applied force in the direction of the force, direction of the applied force. What this means is that if you apply a force to a body, a body, it will cause force application will lead to change in velocity of a body, of the motion of a body. And change in velocity will lead to change in momentum. That's what the second law is saying. Will lead to change in momentum, because momentum is mass times velocity. If you apply a force on a body, velocity will do what? Change. And change in velocity will change momentum. That's what the second law is trying to say. It says that what? Force is equals to m into v minus u all over t. Or you say what? Force equals to m change in velocity all over time. What this means is that application of force on a body, applying force on a body will change the velocity of the body. And once velocity of a body changes, it says what? Momentum will also change. So in summary, force causes change in velocity, and force therefore causes change in momentum. That's all we are talking about in this aspect. But if you notice, the application of the force does not have anything to do with the what? With the mass. It does not change the mass of the body. Let's note that. It does not change the mass of the body. But there are cases, there are bodies whose mass can also change in the course of motion. Don't be surprised. Yes, we know that what mass is a constant. But for some particles, some bodies, mass can be changing with what? With time. Okay? You can have depletion of the size of a body. I don't mean human being. The mass of a human being is constant everywhere. Even the mass of any object is constant everywhere. Weight changes from place to place. But during motion, some motion happens that mass changes also with what? Time. So based on this, let's watch. We can write our F, if it's along the x-axis, as m dv, that's along x, dt, if we like. We can write it along y. Momentum, force along y. If you apply force along y, velocity will change along y. The vy, dt. We have done all this. If you apply force along what? Z components, Z axis, you have m dvz d what? dt. Okay, dt. So in this case, we are saying that what? In all these cases here, we're saying that what? The only thing changing is just what? Velocity. It's just velocity. You can have a change along the x-axis if the force is applied along the x-axis, along y-axis if the force is applied along y-axis, the body is moving vertically along y-axis or whatever. This is a case where force is applied and is changing the velocity alone. Let's see what about the where mass is also a function of time. In this one I did now, only velocity is a function of time. What does that mean? Only velocity changes with what? Time. We should not also forget that what? This is also equal to ma. This also equals to ma. Because change in velocity over time is acceleration, if you agree with me. Change in velocity over time is acceleration. Actually, you can see that from v equals u plus at. You can say v minus u equals to at. You can say a equals v minus u all over t. Since we know that what now, dynamics also include incorporates all the words kinematics equation. So this is your A. This is your A. You can see it here. So it's also MA. So in this case, I will say equals to MAX, acceleration along the x-axis. This is what? MAY, acceleration along the y-axis. And this is what? MAZ, acceleration along the z-axis. Okay? Now, you can see here now, M is ft, a function of what? Time. M is a function of what? Time. That means that what? Mass changes with what? Time. That means both M and V, in this case, are functions of time. Are functions of what? Time. Okay? That means mass changes with time, just as velocity is changing with what? Time also. So based on this, our equation will be written like change brackets mv over t. Or if it's calculus, we'll say F equals d mv dt, the mv dt, which means it's not only v that is changing, m is also changing. That's the meaning. If we differentiate this thing, It will be by what? We use product rule to differentiate it. Product rule. So differentiation by product rule. Product rule. Differentiation by product rule. So we now have F equals, yeah, let's go. Old M differentiate V with respect to time. Plus, that's product rule, plus old V differentiate M with respect to time. If you remember, if I ask you why product rule, you say the Y yes will be equal to old differentiate V with respect to plus old V and differentiate V with respect to X. That's product rule. This is called product rule. This is called product rule. So in this case, both mass and velocity are changing. And that means we have this. In a case where the M dt is 0, what does that mean? It means where mass does not change with what? Time. In the case where mass does not change with what? Time. You have the M dt as 0. That means the whole of these parts will be 0. You are left with this, which was our initial equation. If you can remember, that was our initial equation. All these ones, along X, along Y, along Z. Or just simply say F equals M dV dt. M dV dt. M dV dt. This is our equation. Okay. So let's look at what do you call change in momentum? So you have what? F equals M into V minus U all over T. That's from this equation, second law, from second law. I'm ignoring the calculus parts. Don't say calculus, we do calculus. Make questions on calculus, we do it on calculus, okay? But just remember that this equation can be written like this, and can be written like this. If it's what? If mass is constant. These are things I want you to remember. But in general, F is this, in a case where mass is constant. This for constant mass, where mass is not changing with time. And based on that, we can say Ft equals M into V minus U. Ft equals M into V minus U. We can say what? Can say Ft equals MV minus MU. What have I done? I only opened the brackets to become this. Nothing special. What do you call mass times velocity? Is momentum. So mass times final velocity is called final momentum. This is final momentum because it contains final velocity. Mass times initial velocity is called initial momentum. Initial momentum. Initial momentum. And this whole thing like this will be called change in momentum. Change in momentum. Change in momentum. Change in momentum. So you can see that word. What do you call Ft? What is Ft? Ft is called impulse. Can therefore conclude that one of the implications of second law is that we are able to establish that what impulse is the same as change in momentum. Change in momentum. Please, we must note, always consider the direction of velocity when calculating, when solving. Always consider direction of velocity. Always do that. Always do that. Why? Why should we always do this? Because velocity is a vector quantity. Velocity is a vector quantity. So the direction of velocity is important. when we are solving questions. That's second law of motion. That's second law of motion and implication. Let's see, what are the units? Let's see units and dimension. Let's see units and dimension. Unit of momentum. Unit of momentum is actually kilogram meter per second. Why? Why is unit of momentum kilogram meter per second? Because it's mass times velocity. Mass is kilogram. Velocity is meter per what? Second. That's units. Kilogram meter per second. That's a unit of momentum. Let's see what is the unit of impulse. Remember, impulse is the same as momentum. Even if it's change. Change in momentum is still momentum. Yes. Change in momentum is still momentum. Change in volume is still volume. Change in mass is still mass. So since impulse is the same as change in momentum, it's also the same unit, kilogram meter per second. Or you can say it's Newton second. Why Newton second? Why Newton second? Because force times time. Force is Newton. Time is second. That's Newton second. What's dimension of momentum? Dimension of momentum and impulse are the same thing. Dimension of momentum and impulse are the same thing. They are both capital M. Capital M stands for what? Kilogram. Meter is capital L. Then second is capital T. It's -1. This is dimension. This is dimension of momentum. Also dimension of what? Impulse. I repeat, impulse and momentum have the same dimension because they have the same units. Okay, let's see. Let's see what's it called? We have looked at dimension of what's it called? Momentum and what? Impulse. Well, let's look at collision. Let's look at collision immediately. Collision. Please write. Collision. I made a statement here. I said, always consider the direction of velocity. Very, very important. If a body moves this way with 2 meters per second, another body collides with it, moving at 3 meters per second. Because these are opposites, one and any of these must take negative. I say one and any. Watch that word. One and any. No one deserves to take negative. One and any can take negative. We will explain when we start calculations. What is collision? That's impact between what? Two bodies. When two bodies make impact on each other, when two bodies exert what? Impulse on each other, we have a collision. When collision occurs, what happens? There is momentum. There is momentum loss. Momentum is lost by one body. It's lost by one body. By one body. Quote my word, lost. Quote my word very well, lost. Quote it. The momentum lost by one body, that momentum is gained. Momentum is gained. Or yes, the momentum is gained. The momentum lost by one body is gained by the other body. It's gained by the other body, by the other body, by the other body. Watch that word. There's momentum lost by one body, which is gained by the other body. Which now means that what? In collision and on overall, there is no loss of momentum. That's the meaning on overall. Because somebody lost -2 kilogram meter per second, that's the unit of momentum. Somebody gained +2 kilogram meter per second. At the end, what's total loss or gain? 0. There's no loss or gain of momentum on overall. And this is called principle of conservation of momentum. That's called the principle of conservation of momentum. Principle of conservation of momentum. So if you're asking us, state the principle of conservation of momentum, you will say that what? It states that in a system of colliding bodies, bodies, total momentum is always conserved. Perfect. Or you say in a system of colliding body, the total momentum lost by one body equals to the total momentum gained by the other body. That's all. It emphasized that momentum is never what? Lost. Even though one loses, other what? We gain it. One loses it, other we do what? We gain it. The lost momentum by one is gained by the other body. At the end of the day, nothing is lost. The daddy gives you 10,000 naira. Daddy has lost 10K from his pockets. The 10K is with you. On overall, we don't need to look for the 10K gain. We know where it is. Lost by daddy minus 10, gained by you plus 10. Total is what? 0. That's circular flow of income. Your money will be somebody's money. Somebody's money will be your money. At the end of the day, total money in circulation must be the same thing. Okay? Circular flow of income. So that's principle of conservation of what? Momentum. Okay. Now, there are 2 types of collision. We have 2 types of collision. We have elastic collision. What is elastic collision? Elastic collision is a collision in which what? Energy is not lost. Energy is also conserved. Energy is not lost. Just as momentum is conserved, energy is also what? Conserved. That's called the principle of conservation of momentum. The bodies collide. And after collision, they move separately after collision with different velocity. This is what? Body 1, body 2. Before collision. This is before collision. This is after collision. After collision, the body moves separately after collision. This is what? Mass M1, initial speed U1. This mass M2, initial speed U2. These are their masses and initial velocities. After collision, their masses remain the same. M1, this 1, this 2. But their velocity have changed from U1 to V1. U1 has become V1. Here, mass M2, then V2. Now watch. If, let's say U1 is 10 meters per second. After collision, V1 becomes 7 meters per second. That means what? Body 1 has lost momentum. Why? The speed has reduced from 10 to what? 7. Where is that increase? Decrease in speed. Let's say initially U2 was 5 meters per second. V2 now becomes 10 meters per second. Here has gained speed. That one has gained speed. Don't say, but here lost 3, it becomes 7. Here gained 5. No, that's not how to calculate it. We are looking at the what? Momentum, not the speed. But increase in speed means increase in momentum because mass is constant. But the increase in speed do not correlate. You can't see because here from 10 became what? 7. It has lost 3. Here should gain 3. 5 should become 8. No, it doesn't work that way. It doesn't work. But there's a decrease in velocity here from 10 to 7. There's an increase from 5 to what? 10. That's what matters. So as one loses momentum, who gains that momentum? At the end of the day, M1U1, initial momentum of body 1, plus M2U2, initial momentum of body 2, must give us what? M1V1, final momentum of body 1, plus M2U3, final momentum of body 2. This is what happens. This is called the conservation of momentum. This conservation of momentum, meaning you have lost nothing. In the system, there's no loss of momentum in general, because total momentum before they collide equals total momentum after they have collided. That's it. They will now have what is called inelastic collision. Don't forget that what? Okay, let's see the energy conservation for elastic. Energy conservation. It says what? Kinetic energy is conserved, meaning you don't lose kinetic energy also, which means that what? Half M1 U1 square. That's the kinetic energy of this, of body 1 before collision, plus half M2 U2 square. Remember that word? Kinetic energy is R times mass times mass times. Remember that. So this is what? For body 1, the mass is M1, velocity is U1. For body 2, mass is M2, velocity is what? U2. So that's it. Equals to the kinetic energy after collision, half M1 V1 squared plus half M2 V2 squared. This is called conservation of energy, which means energy is also not lost. You do not lose energy as well. That's conservative principle for both momentum and energy. Number 2 collision is called inelastic collision. Inelastic collision. What do you call inelastic collision? A collision where there is loss of energy, meaning there is no conservation of energy. Energy is lost, meaning total energy before collision and total energy after collision are not what? The same. They are not the same. Energy is lost, but loss is in quotes. Because if you remember the principle of conservation of energy, the principle of conservation of energy says that energy cannot be lost in any system. But here we say energy is what? Lost under inelastic collision. They will ask you, still justify that what? The principle of conservation of energy still hold for life. Justify that principle holds. Yes, the principle holds because the lost energy in this collision can be harnessed to do something else. It can be used to do something else. Okay? That energy lost during this collision can be used to do something else. The heat produced in the collision can be used to make tea. You drink it. Yes, and the thing you drink gives you chemical energy. That's food, chemical energy. The chemical energy can help me to do what? To work, to teach you. It's not wasted. When I'm exhausted, when I use that energy to teach you, it has been useful to teach you. You gain the knowledge and use it somewhere else also. Energy is never lost, even though inelastic collision says there's a loss of energy. Take note, they can ask you, does this statement still justify the conservation of energy principle? Yes, it does. They will not ask you, where is now that lost energy? Tell them that it's used to do something else. Or you say it's converted to another form of energy. For inelastic collision, loss of energy. 2, the body moves separately. I mean, the body moves together. They coalesce. Coalesce. I don't know if this spelling is correct. Coalesce. They join together after collision and move with the same velocity. This body 1, body 2, body 1, body 2. They've moved together with the same velocity. This before, this after, and they are stuck together. They collide and they stick together. This is what? Mass F1, U1, mass of 2, U2. This is now what? M1 plus M2, they are together, times V. They are together. Momentum is still conserved. Remember, momentum is always conserved. Momentum is always conserved. Momentum is always conserved. So conservation of momentum. Conservation of momentum. Conservation of momentum. Conservation of momentum. What do we have? We have M1 U1 plus M2 U2 to give M1 plus M2 times V. M1 U1 plus M2 U2 equals to M1 plus M2 times what? V. Okay, you can see. There is no conservation of energy. No conservation of energy. No conservation of energy at all. How? Half M1 U1 squared. That's the kinetic energy of 1 before collision. Plus half M2 U2 squared. This is the kinetic energy of 2 before collision. Of 2 before collision. Is it equals to half M1 plus M2 times V squared? Can somebody answer me yes or no? Is it equal?
No, sir.
No, it's not equal. You can see it's not equal. Some people are not talking to you. Are they equal?
No, sir.
No, sir.
No, sir.
Good. So there's no conservation of what? Energy. They're not equal. Thank you. Thank you. That is what? Momentum. That's momentum. Now, let's go to the last thing today. Last thing for today. Coefficient. Coefficient of restitution. Coefficient of restitution. What is coefficient of restitution? It is a measure of elasticity of a collision. It measures the elasticity of collision. And the coefficient of restitution is given as, that's the formula, relative velocity of recession all over relative velocity of approach. Take note of that statement. Relative velocity of recession over velocity of what? Of approach. It is given as minus brackets, just watch please, is given as minus brackets V2 minus V1 all over U2 minus U1. There are so many ways of writing this thing, many versions, but I go with this version. So 2 under 2, 1 under 1. So V2 minus V1, remember that what now? Your velocity on top over U bottom. V is on top, V is at the bottom. V is for recession, when they recede each other, when the body are going away from each other. When they're for today. The this is the class we end for today. Now, this thing, is on YouTube. So please kindly watch on the YouTube also and subscribe on the YouTube. You can send this video to your friends to also watch and subscribe. Okay, so kindly do that. Send to your friends, watch and subscribe to this YouTube channel. More videos will be on it so that you can know that what most of you will not have what's it called? You want to do this thing at your what convenient time, to read at a convenient time. So you can use this to read, but you should also form your notes. You must form your notes. So you can send to your friends, send to your enemies, send to everybody. Watch and please subscribe. Thank you. We stop